Hi everybody, this is going to be a video over Quiz 2 material. So just kind of like a quick review. Remember that Quiz 2 will only cover geometric sequences and series, including the infinite geometric series. So that's what we're going to be talking about in this video here today. I try to make all of these questions similar to what you'll see on your quiz so that it'll be a useful review for you guys. So here's the first kind of thing that you would have to know how to do. Given a sequence, I want you to know how to write a rule for that sequence and then find a particular term. So if I want to write a geometric sequence rule, we're going to be using the formula a subscript n equals a1 times r to the n minus 1 power. So we need to find a1 and we need to find r to be able to write that rule. Now a1's easy, it's just your first term, and then r is pretty easy to find as well. It's just the number that we're multiplying by each time. And for this particular sequence, I can pretty easily tell that I'm going to be multiplying by a -2. So once I have that information, I just have to plug it into this formula here. So I would get an equals 3 times -2 to the n minus 1 power. So this is my rule. And if I want to then find the 8th term, it's as simple as just plugging in 8 for n. So let's see, we want to find a8. So we're going to do 3 times -2. And if I plug in 8 for n and then subtract 1, that's going to give me a 7 here. So now if I do this calculation, I'm going to get -384. So that would be my 8th term. Now, when you're making this calculation, don't forget to include the -2 in parentheses, raise it to the 7th power, and then the last thing that you should do is multiply by 3. Okay, so you're following your order of operations here. So let's look at another one very similar here. So again, we need to write the rule, find the 8th term, so we need to find the first term and the common ratio first. Now, with this one, it's a little bit harder to find the common ratio. Okay, my first term is still easy. But my common ratio, I'm not too sure just by looking at it. So since we know it's geometric and we know there has to be a common ratio, what I would do is I would just pick 2 terms and then take the last one that you choose and divide it by the one before it to get that common ratio. So 40 over 60 is going to reduce to 2/3. And then we can verify that we are in fact multiplying by 2/3 each time in this sequence. So now I have my common ratio as well. So let's go ahead and write our rule. And then if we want to find the 8th term, just like last time, we're going to plug in 8 for n, and then use our order of operations to calculate further. So this time we're going to get 7.9. And I rounded a little bit there. We can just go out to that tenths spot. So maybe you start with something like this instead. We have a little bit of a different information given to us. We're not given a sequence, we're given the 5th term, and we're given the common ratio. Now, the nice thing here is that it does tell us that it is geometric, so we know that we can apply that formula that we were using in the previous problems to help us out here. So here's what I would say. We have some of this information. Okay, if I know the 5th term, let's use this formula and kind of set it up for the 5th term. So if I have the 5th term as -68, that means that when I plug in 5 for n, it should give me this value. So let's fill in what we know. So 5 minus 1, so that would be to the 4th power. Now, I'm going to go ahead and I'm going to start solving this. So if I raise that negative 0.5 to the fourth power, that's really going to give me 1/16. And then to divide by that 1/16, or we can multiply by the reciprocal, which would just be 16, that's going to give us A1, our first term, equal to negative 1088. And you could always do some work to verify that this is correct. If we went back here, if I wanted to make sure that this is my correct value, then we should check and make sure that negative 68 is equal to this value that we just found times negative 0.5 to the fourth. And we can go through and we can find that, yes, this does in fact give us that correct value. And that's just a way that you could verify that you have the correct answer. You don't need to do that, but if you're not sure if you solved correctly, you could go through that process. So let's talk about series here. Now, remember, a series is really just the sum of a sequence, and this is our summation notation, which is telling us that we are summing up the second through the 11th term in the sequence generated by this formula right here. So there's some information that we need to find before we can use that special geometric series formula. So just as a refresher, I'm going to do it off to the side here. That formula that we'll be using is A1 times 1 minus r to the n power, all divided by 1 minus r. So we need to find our first term, which in this case, since we're starting at 2, our first term is really going to be A2. Our common ratio, and then n, remember, is the number of terms that we are summing up. Now, here's the nice thing about summation notation. Since we're already given a formula, we can look in this formula here to find our r value. The number being raised to the power is always going to be your r value. So right here we can see that for this problem, that's going to be 1/2. Now, since we know that we're summing the second through the 11th term, we can count pretty easily how many terms that would include. Now, keep in mind that the difference between 11 and 2 is 9, but since we're actually including the 2, there's really 10 terms here that we're summing up. And then the last thing we need to do is find the second term, which is pretty easy because all we need to do is plug in 2 to our formula right here and make a calculation. So if we do that, we're going to find our second term is 40.5. So at this point, I have all of the information that I need, and I'm ready to calculate this series. So I'm using my formula that I have off in the right corner here. So 40.5 times 1 minus 1/2 to the 10th power, all divided by 1 minus 1/2. So if we go through this calculation here, we're going to find that this sum is about 80.9. So that means if we took the first, not the first, but if we took these 10 terms, the second through the 11th, and we added them all up together, it would sum up to be 80.9. Now, the last thing that we're going to really talk about here are these infinite geometric series. And you know that you're working with an infinite geometric series when the sum goes up to infinity here, okay? So before we start using any of those special formulas, you have to ask yourself, is it convergent? Because that's really going to decide how much work there is to do. If you find that your series is divergent, then you just say it's divergent and you don't specify the sum that it approaches, because it could be positive infinity, it could be negative infinity, or it could be impossible to decide at all. So we only care about convergent geometric series. Okay, and to decide if a series is convergent, you should be looking at that common ratio. If the common ratio, when you take the absolute value of it, is less than 1, then it's convergent. So remember that our R value is given to us right here in the geometric sequence formula. So we're just testing, is the absolute value of 1/5 less than 1? Yes, so that tells us that this is convergent, which then tells us that we can use this second formula that was given to in your notes, which is just A1 divided by 1 minus R. So this formula is only used, that's a horrible R, this formula is only used when we have infinite geometric sequences, or series I should say, that are convergent. So we need to find our first term and our common ratio. Okay, our first term is going to be the 250. And we said that this 1/5 is going to be our R value. So we have all the info we need to set up our formula. So it would be 250 divided by 1 minus 1/5. So if we do this calculation, we get 312.5. So that means that if you take an infinite number of terms from this sequence, starting at the first up to the infinite term, if you add those all up, the value of that sum is going to converge, meaning it's going to get like really, really, really close to 312.5 here. So let's take another look at one. Okay, so we need to ask ourselves, since this is an infinite geometric series, is it convergent or divergent? So this is our A1. This is our R value. So we need to check and see, is the absolute value of -2/3 less than 1? Yes, so that tells us that this sequence, or I'm sorry, this series is convergent, which allows us to then find that sum. So the formula is A1 divided by 1 minus R. And if we do this calculation here, we're going to find that that sum is going to approach or converge to -1.2. So let's take a look at two more here. Okay, another infinite geometric series. I keep saying sequence here. But what I notice is that R value is not less than 1. So that tells us that this sequence is divergent. So this series is divergent, and we can't calculate the sum. It's not gonna converge to a specific value necessarily. Now, I would argue that with this one, we start with a half and we multiply by 5 over and over and over and over. So each term is going to be bigger than the last. They're all positive. So we could say that this series is going to approach positive infinity, but we can't say that for all of them. So let's look at another. Okay, this will be our last one. This is another infinite geometric series. And if we look at that R value, we have another one where the R value, when we take the absolute value, is not less than 1, which tells us that this is divergent. So there's not a particular sum that it approaches. And with this one, we can't say negative or positive infinity because the common ratio here is negative, which means that our terms are going to alternate between positive, negative, positive, negative, positive, negative. And there's no good way to determine if the sum, when you take an infinite number of these terms, is going to end up approaching positive or negative infinity. There's really no way for us to know. So we don't need to specify. You would just say that it's divergent and that you could not find the sum. All right, guys, I hope this was helpful. This covers everything that would be on your second quiz for Unit 10. So please let me know if you have any other questions, and have a great day.